It's just like a I know exactly. They're just a big story.
Yeah, I get you.
Oh, what?
Morning. You bet. From my couple of words. Austin. One. Jose. And Justin. Oh, sorry about that. Jenna.
It's good.
Anyone else? Name? Adrian? Anyone else? All right, please finish the question on the board. If you have your answer, let me scan them. This is for today's attendance. Yeah, I did. If you have a plus, that's the extra credit. Even that one is added in the file. Yeah, in the file. Because the actual credit for the homework and the bonus question, that's why the class averages are actually higher than. Anyone else? Your answers. The calculation goes like this. We would factor the x from the numerator. The numerator has 3 terms, so all 3 terms has x. And therefore, the x is a common factor in the numerator. Common factor is typically a multiplication. One of the terms that is multiplied is considered a common factor. So you can see they all have x. So what you can do is you factor the x outside the parentheses.
Actually, I actually didn't finish
All right. And that way, one of the x is long, is factored outside parentheses. So become this. That would be filling our okay, so this is typically what you should do first. And then you can cancel the common factor x because numerator and denominator both have a factor of x. So let's, all right, so you can see there's this is a factor, but this is not a factor. A factor has to be a term that you multiply with other factors. So this, they're not factor. So you can't cancel this x with this x or cancel this 5x because they're not factors. Subtraction does not count as factor. Addition does not count as factor. only one term multiplied with other terms, both terms are considered factors of each other. So now after you factor the x out, x is multiplying all three. So x is multiplying the entire, for instance, the entire polynomial. X is a factor, and this degree 2 polynomial is a factor. There's a factor x in the numerator, there's a factor x in the denominator. So x is considered a common factor because x exists in the numerator and in the denominator. That's why we cancel the x. After you cancel the x, we were able to look at a limit calculation where there's no 0 divided by 0 anymore. And that's kind of the reason we want to calculate it this way. You cancel this x with this x. Okay. Now we're able to calculate it with substitution. At the beginning, if you substitute the x equal to 0, then this denominator equal to 0, numerator is 0. Therefore, obviously, substitution did not produce a valid answer. So we have to look for other ways. Whatever 0 divided by 0 is happening with substitution, it's being called an indeterminate case. That means you cannot determine by substitution. So we have to find an alternative way. And what we can do is change the format of the question. So now this new format has the same limit value as the old format. They're not the same function, but they do have the same limit. And therefore, we can now let x approach to 0, and then we can calculate it. So if you have a different answer or you haven't really submitted your answer yet, let's submit them. Yes. Hope everybody have already submitted. Let's see. It looks like Ernest was absent today, and Ernest absence. Let's see if Sarah you all have your test question. The answer to this question is -5/5 because the other one are 0. You can also think of it in mathematics. There's one branch is called analysis of order or analysis of degree. Because if you think about x approaching 0, there are 3 terms in the numerator and 1 term in the denominator. The denominator is degree 1. So it has a lower level of 0. 0 is the higher the order, the smaller the number. So 5x and -5x is actually the same quantity. But 12x squared, when x equals to 0, 12x squared have a high order of 0, which causes to be much smaller. So when x approaching 0, the higher degree actually means a higher level of small. So small because it's approaching 0, so small, smaller, smallest. Because these two are so small, it's not comparable to that one. Therefore, they can just be. You can assume that they're already 0, and then the final answer should be -5x/5x. So sometimes compare the degree of the polynomial also indicated what should be the right way to calculate it. But normally in the textbook, we follow this method. In the textbook, we always look for common factor between numerator and denominator, figure out a way to avoid having 0 in the denominator, avoid having the 0 in the denominator. After cancel the x, the denominator is no longer 0. Can be calculated in substitution. So, we'll finish the test. This test we have extra credit from the homework, and there's 1 bonus question. Not everyone figure out the bonus question, so I try to look at your solutions. At least 1/3 of the class do have the right answer for the bonus question. That's why it kind of boosted the grade a little bit more. So then the overall, we have an average. I put the data online. This is the class average. We have 31 students in the class. 29 attended the test. The final average is 91. So it's a pretty high average. Consider we actually move it higher than. There are a couple of students that had their score higher than 100. That's because they did a bonus session. They also submitted their homework on paper, so I give them extra credit. Any question? Well, if you wish to take your test again, so for example, we have two students missed exam. And then if you made a grade that you are not happy with, you're welcome to retake the test. But then that opportunity have to be taken outside the regular class time. I normally give student makeup test in the testing center. Upstairs, student 201 is a testing center. So if you wish to take it, that opportunity is available. I assume most of you are okay with it so far. We have 3 more tests coming up, and I dropped the lowest test. So if this is the one that are lower than expected, you still have the opportunity to make it up later. Yes.
The makeup test, they work the same way as the.
Yes, I normally take the higher one. So sometimes I have students that they decided to take a makeup test. It actually ended up lower than the original one. So I would probably, there's no penalty to take it if it's lower. But it's really taking a chance. I mean, the makeup test would be similar to the one we already did. So just different type of question. As you can see, this one, I think it's pretty similar to the practice question, right? The format is the same type of question. I actually try to make it slightly easier on the question 3, because I thought if I make it an actual number, the final answer will be a number. Originally, I was planning on to calculate limit with a, f of a plus h minus f of a over h, finding that limit. But then I realized that will be abstract, so that the answer will be a formula instead of a number. I switched to a number 4, hoping that will be easier. It's still kind of hard for most of us because I see a couple of wrong answers for number 3. So that I was showing that when you have an abstract notation in your question presentation, it causes a difficulty when you try to rewrite your question. All right. So let me try to work out the question number 3. You have it wrong. Right, so for our number 3 is really you have a question?
No, it's just such a I'm sorry.
So it's really a limit calculation. We want to calculate the limit of f of 4 plus h is f of 4. So that's subtraction of the y value, and it's divided by h as h is approaching 0. That's the limit calculation we were supposed to do in question number 3. In order to write this out, we kind of have to know what is f of x exactly. F of x is being defined as addition is 1 divided by x minus 2. I see many of you had the right answer because you did calculate the limit by there are a couple of ways to do this. I mean, I can see as in your effort trying to find the limit, many of you did use a numerical method. You plug in h that is super small and try to find an estimation of the limit value. You can also calculate the formula, which is the intended way. We hope to find the limit analytically. And of course, if you can graph it, you can also figure out the graphic, the value of the value. All right, so how do we write it out? This one, we're able to, it's a fraction, so it won't be as lengthy as a big polynomial. So what we can do is to write it out, the f of 4 as of 4. It equals to 1 over 4 minus 2. So it's literally the fraction 1 over 2. So that's the f of 4. And then we want to write the f of 4 plus h. And so that will be f of 4 plus h. These are the building blocks. They're not the answer yet, but it helps to analyze this a little. So you will use the 4 plus h to replace the x. 4 plus h and 4 plus h. So the denominator will be 4 plus h replace x, but you still have the minus 2. That's how it is. It helps to simplify. I see many of you just put the whole thing in there, and then you end up having to think of these as two different factors, but they are not. 4 minus 2 can be combined, so it makes your final fraction slightly easier to present and slightly easier to carry down with your calculation. So this end up being 2 plus h, because 4 minus 2 is 2. So that's what will happen for alpha 4 plus h. That is the two term that's supposed to subtract in the numerator. So what we're going to do is we search out the numerator and have the 1 over 2 plus h minus 1 over 2. Okay, so when we apply the F definition, we're able to write these two, and then the limit calculation turn from a very abstract notation into a calculation that can be calculated. From here, you have the opportunity to make h equal to a really small number to estimate the value. You can make x equal to 0.01 and plug in there. H is a super small number, and you can see the numerator will be really small. The denominator will be really small. So this is also like a 0 divided by 0 case. One of the effort is try to figure out if there's h in here. If there's h factor in here, we can cancel that h. That deal with the fact that we have a 0 divided by 0. When h is canceled, we no longer have 0 divided by 0. We can then go ahead and calculate the value. All right. This is similar to what we were doing yesterday. There's a fraction that we have to calculate in order to subtract the fraction. We need to have common factors. So what we can do is we make the common factor this term times that term. So it's the multiplication of the two is going to be the common factor we're looking for. So we're going to have the 2 multiplied by 2 plus h. We're also going to have a 2 multiplied by this. So as we were trying to make the denominator the same, we are changing the format of the fraction. But if this becomes this, we're multiplying the denominator by 2, we also have to multiply the numerator by 2. So instead of 1, now we have 2 in the numerator. Same thing here. If you turn from 1 over 2 to 1 over 2 times 2 plus h, then the numerator should multiply by 2 plus h. Just to be consistent with the value, this one has to equal this one for it to equal. The numerator has to multiply by 2 plus h. All right, so from here to here, there's no change. Many times in the mathematical calculation, we're changing the format from one to another just so the calculation can be completed. So now we work on the denominator is now finished, and now we can work on subtracting the numerator. When we subtract the fraction, we will have common denominator, and then we subtract the numerator. Denominator has to keep that format. And start from here, one of the common thing that people do, they start multiplying the denominator. There's no need to multiply the denominator. Right now, the denominator is in a multiplication format. That's what I consider a factor, another factor. It's not necessary. Well, it doesn't hurt to multiply 2 times 2, 2 times h, but if you keep this format, I think it's easier for limit calculations. So we're going to keep that. Time. So when we're doing this, we would still try to calculate everything in the numerator and become a common denominator 2 times 2 plus h. And the numerator can be worked out by the subtraction. So I have 2 minus -1 times 2. So that's minus 2 and then minus h. That's the calculation that happens in the numerator. The numerator is the same. As you can see, subtract 2, subtract h is the distribution of the negative factor. These two belong to the denominator, which is already here. So we don't have to worry about anything in the denominator, only everything in the numerator. And now, because 2 minus 2 equals 0, there's only a negative h. So what happens now is finish the subtraction. Now we have this. 2 minus 2 equals 0. So that is All right, so we have a negative h in the numerator, we have an h in the denominator. Cancel this two. We have this limit. I guess I should connect them with equal sign. So cancel the common factor of h, then that leaves you a 1 here and a 1 here. All right, and then well, division by 1, you can ignore that. It's 1, like 3 divided by 1 is 3, so that one skipped. So h approach to 0, this is 0. Then the denominator will be 2 times 2 is 4. The final answer is negative 1 over 4. You can also write a negative 1 over 4. They're the same thing. So that's the answer to question 3. If you had it differently, if you have a different way to write it, as long as the final answer is correct. So the calculation process is actually different from people to people, but as long as you figure out the final. So numerical calculation always is slightly easier than calculating the entire derivative function. Any question? Any other question on the test you prefer explained? I did look at our homework completion, and this chapter is pretty good. I see most of you, almost everyone that has the paper homework and had all their homework finished. So I'm not I haven't really checked for the entire class, but I think the homework was good. So yeah, I did assign a whole lot of homework. I still feel like that's not enough because we only get 10 questions. Limit is a big thing in calculus. There's always a different variety of question that we hadn't had an opportunity to practice them. And you might see them later in physics class or engineering classes. I always feel like there's something that we haven't touched on. When we're talking about limit calculation, and understanding limit will always be, I hope, a persistent topic so that we get better and better learning it or understanding it through the years. Calculus is something I always feel difficult when I was in college. At first, it's especially the epsilon delta definition. It's really difficult to understand. I think I really felt like I had completely understand it when I was in graduate school. So it takes me a couple of years to actually feel confident about it. So I kind of understand when you're learning it fresh, if you're a little bit empty or nervous about it, it's understandable because it's a new way of looking at process of calculation. And you can see limit calculation can be calculated by substitution, but it doesn't always work out. For example, here if you substitute h equals 0, there wouldn't be no answer. But here, if you substitute h equals 0, there is actually an answer. So there is a variety of questions that a simple substitution does not work, and then that causes a change of method. And there are quite a few methods. Some of you mentioned L'Hopital in the limit calculation, but I feel like L'Hopital is after we have the derivative topic, and after we have the derivative formula. So it's something that doesn't not always work, and it also have a condition. So on certain condition, you're able to apply L'Hopital. On certain condition, you can't. So then we do have to practice in order to understand how it works. Any homework question? Sign 2.1 and 2.2. Any questions? Yes.
Basically, like the two that are kind of confusing right now are section 1.2.4 with problem 4 and 5. So right now, I just wanted to look over 4 first.
You mean this assignment? 2.1?
Yeah. 2.1 problem 4.
Yeah, I understand this one is another practice. So we're trying to practice writing all this thing. And we've been doing this kind of limit, kind of like the number 3 as well. Try to figure out how do we handle it better. This is similar. This one has a root, so similar to the one we had on the practice question. Whenever we have subtraction roots, it often causes a division by 0. We have to fix it by multiplying something that helps the division change its format. So let's write this out to see. So this question was try to write this out to get a expression that's easy to calculate. Right now, if you enter h approaches 0, numerator denominator both approach 0. That's why we want to change the format. We want to simplify it. So we will write it out. If you are not sure, it's easier just to write individual pieces and then put it together. So the first thing we wanted to do, maybe we write out f of x. According to the definition, f of x is right here. -8 plus 4x. So f of x. So that is, you can take it straight from the definition. That's the f of x. All right, and then we have f of x plus h. That's the one we do have to work out the substitution. This follows the same definition, so it's -8 plus 4, x plus h is in the root. Everything else you were supposed to copy. So it's going to be -8 plus 4 times root of the input. The input is x plus h, so it's root of x plus h.
How do you type down the square root value like on what?
I think it's SQRT. So suppose you want to enter square root x plus h. You would do SQRT x plus h on what word?
All right.
All right, let's try to finish this and then I'll work out the input on what word this is. So if you want to subtract them, they look like this. So f of x plus h subtract f of x will look like a subtraction of the exact two things. We will take this one and I'm going to subtract x and subtracting this one. I'll just copy it over because it saves time. But if you're writing on paper, you will write by piece. All right, so this is what subtraction you subtract the first expression with the second expression. So then we're gonna start removing the parentheses. So if you remove the parentheses, it's -8 plus 4 times the square root of x plus h.
Plus 8 minus 4x.
Right, it's gonna be plus 8 minus 4x.
So basically, like the 8 basically being cancel each other out.
Yes.
Basically, and that and basically the part where this and that and here this is also that's all. Like once you cancel it, all the part that I was that's the part that starts to get me.
Okay. Yeah. So we would cancel the -8, cancel the +8. Right, and the +4 is okay. We can skip that part, and then let's try to push it together. All right, just want to put it closer together. This is now the f of x plus h minus f of x. Basically, the constant number is subtracted because it's constant in both terms. Now it's gone. The variable term is only the one that matters. So now let's work out the division. So this entire division. Okay, that is equal to this numerator divided by the denominator. Now we normally would try to simplify it because if h approaches 0, the numerator is 4 root of x minus 4 root of x. So it's going to be a 0 divided by 0. So we're hoping to simplify it. So somehow, see here, somehow there will be not an h in the fraction. So change it. We multiply something that's instead of subtraction, we multiply summation. Summation of the two roots is called a conjugate. We do this. This is equal to, I prefer to put the 4 aside, and then we have root of x plus h minus root of x over h. So 4 will be an individual number to the side, if that's making it slightly easier. Simplification only happened here. You copy the 4. 4 will be combined into the a later. So we're going to work on this one. We multiply the conjugate. That is, the conjugate for subtraction of root is the same term. You switch the sign to a plus because the summation normally do not cause a problem because if any one term goes to 0, the summation still produces a valid answer instead of 0. So we multiply this by root of x plus h plus root of x. And we have to multiply the same thing in the denominator. Okay, this step is very important. See, many of you are doing the same thing with the bonus question. In the bonus question, there's a subtraction of root terms, and that is the one we have to multiply the conjugate to just try to verify. Now, the calculation afterwards is very important. We would try to multiply the numerator part of it because that's the reason we're doing this whole thing. Because it allows you to find a way to get rid of the fraction. So let me try to use an example. So why we're doing this? Because if you have a root of a minus root of b, and the conjugate of this term is root of a plus root of b. So this is multiplication of conjugate. This is conjugate of this. This is conjugate of this. If you multiply them out, you see we were supposed to follow. If you follow, you have root of a times root of a, which is a. So that's the first term. And then you have root of a times root of b, which is root of ab negative so ba. Well, ab, same thing. All right, and then you multiply the first term with the last term, that is root of AB, but it's positive. It's positive root of AB.
And with that would then the ABs and B's we cancel each other out.
Right, yes. So these two cancel each other out. And that means that the entire complicated multiplication of a root term end up having a final answer equal to a minus b. Which is nice. There's no more roots. And that's kind of part of the reason we want to multiply a conjugate to the numerator. So it happened here as well. This is A, this is B, this is A, this is B. So after you multiply this one times this one, give you x plus h. This one times this one give you negative x. The intermediate term, these two multiply is negative, these two multiply is positive, they cancel each other out. So the final answer in the numerator, it'll look like this. So this is equal to 4 times, the numerator is going to be x plus h minus x. All right, and then that's all there is because the root term was canceled. They were opposite sign, you canceled. This two multiplication, you follow this, you can see what it is. You can try to follow this, and you can see there are similarly, even though I'm using completely different letters for the variable, but they do have very similar outcome, that is canceling out the roots. So after you multiply the numerator part, there's no more roots, and also we have x plus h minus x, and the x minus x obviously equal to 0, so you only have h left, and that is the nice part of it. And that's the whole reason, because we want to cancel the h in the denominator. Now you have the h in the numerator. Denominator, And this is something I want to tell everybody. Do not multiply everything. We multiply the numerator with a purpose because we want to get rid of the roots. But we are normally okay having the summation of roots because if x goes to 0, it's root of x plus root of x. There's no problem there. So that part will just keep it. And it becomes this. Become roots of h times root of x plus h plus root of x. So we don't have to multiply the denominator out. We don't have to multiply h with this, h with this. And it's actually important to keep this way because now h is a factor. We are able to cancel this factor with that factor because you see x minus x, it is 0. So we have x minus x. Right, there's no more x, and you see a factor of h right there in the numerator. I cancel that h there. If you did multiply h with this and h with this, and where's the h? So it's not as visible for h as a factor. So try to keep it that way. So then sometimes there is like a reason for each steps, and we don't have to multiply everything every steps away. We think of it, is it better to keep it in a factored form? Or is it better to multiply out? So for this case, it's better to multiply the numerator out because it's simplified. And it's not such a good idea to multiply the denominator because it might remove the fact that we got a factor h. So cancel the h, and that will be the final answer. So after you cancel the h, you will get 4. I move the 4 to the numerator because it's easier to get the fraction and easier to compare with this. Right, now we have root of x plus h plus root of x. So then you can compare with that, and we realize a equal to 4, b equal to 1, and c equal to 1. That's the c that we wanted after we compare the coefficient. Right, what were you gonna say? Oh, this works out as example.
This is and also this is also like part of the this. There's also a second part to this too.
Okay. All right. So now we know that is 4, that is 1, that is 1, and the second part. It says you were supposed to find the limit, right? Right.
All right.
So we were supposed to find the limit, but you realize over here we're finding the limit of this with h equals to 0, right? So if this h equal to 0, it will just be root of x plus root of x.
That would be just like an x.
It will just be, no, it's a summation. It doesn't really get rid of it. If you multiply root of x with root of x is x. But if you have root of x plus root of x, it will just double the root of x.
Okay, so just 2. So basically,
Right.
2 times the square root.
Yes.
Okay. That was an error on my part. Sorry.
Okay. So limit of this when h equals to 0, limit of 4 over x plus h plus root of x. I guess smaller because I'm the most equal space. So it's 4 over 2 root of x. And you can cancel the 4 with 2. 4 divided by 2 is 2, so then it becomes 2 over root of x. So here the answer here is 2 divided by square root. And so far that's the first part. And then we can now calculate the derivative at prime 1. You plug in 1 here. So 2 over square root of 1 now will just be 2 over 1. And this is square root 2. And that there's no other way, like 2 over square root of 2. And then this is going to be 2 over square root of 3. So you plug in the x value to get the derivative. That finished the entire question. Once we finish the limit calculation, we got our derivative function. We just pretty much plug in numbers.
Okay.
Any other questions?
Just remember five.
All you have to do is just factor out one of the H's, right? Right, that doesn't. It says on the news.
All right, you, not only do you have to factor the H, you have to make H go to 0. So we were supposed to, like this is my version of it, let's see how it works. We were supposed to find the relative equal to the limit of H approach 0 of f of x plus h minus fx over h. So this entire expression still have to divide by h, right? So to divide by h, then make h go to 0. So we would divide each term by h. So if you divide these by h, down h. So one of the h is divided by this h to lower the power of h. And then it becomes 3x squared. The h is divided out. Minus 5x. The h again divided out. Minus 6hx. There's h left. Plus 8h. One of the h is divided out. So we basically lower each power of h. The last one is minus 5h cubed now becomes squared because we divide out the h. Are we okay there? And you can see, basically this is all over h. We're supposed to factor the h and cancel the h, but essentially it counts as divide each h. The h gets lowered by power 1. If you only get one h, then you have no more h left. So we have one more step. This is dividing the h, but then we still have to make h go to 0. H approaches 0, then 0, 0, 0. So when h approaches 0, these are all 0. So the final answer would just be 3x squared minus 3x squared minus 5x. That's derivative. You can double check on your part. All the part that has h, if you have h in the fraction, when h approaching 0, 0 multiply anything is 0. So there's 6 times 0 times x, 8 times 0, 5 times 0, it all becomes 0. So only the part that has no h. But they are constant relative to h. When h approaches 0, these terms are related to x. They're not related to h, therefore they will not be affected. So they're considered constant number if the variable is h. That's the solution. Question 5. Any other questions? All right. Let's talk about 2.2. We started it, well, basically 2.2 is not a large section. It's mainly understand the meaning of derivative, and that is, there's only 2. One is to understand the meaning of derivative algebraically, the meaning of the word, and 2 is understand it geometrically. That is, the derivative is really the slope of the tangent. So number 1, derivative value represents an instantaneous rate of change. And it also means that whenever you're trying to find out, hey, this is a relation between this two quantity, what is the rate of increasing of this quantity when the other quantity is this? Whenever we talk about rate of change, rate of increasing, rate of expansion, rate of descending, decreasing. So a lot of time whenever you mention rates, think slope, think derivative. Right? So this is something we have to remember, and rate is really important in even in real world data. And so for a situation we have no function, there is no formula that model the world population, you can still find the slope because all you have to do is what is the population today? What is the population yesterday? And you subtract them. There you have it. That's your derivative value, your rate. So a lot of time, just calculate the rate of change already is your derivative value. And we have a couple examples there. We finish it over here. another understanding of the derivative, which would be the slope of the tangent line. And that one we have a lot of practice already in section 1. The tangent line function can be modeled by the formula derivative time x minus the x value of the point of tangency plus the y value of the point of tangency. That's all there is to model the equation of the tangent line. Now the only thing we should mention more is the relation between derivative and motion. In physics, we talk about this all the time, that the velocity in chapter 1, section 1, we also talked about velocity. We talk about average velocity is actually the slope from this point to that point. The instantaneous velocity is actually the derivative. So if you get a position function modeled by st, then the derivative of the position function is called the velocity function. You can also call that the rate of change of the position function. And that's something we will mention again. And then if you find the derivative again, which is the derivative of the velocity function, that's really the second derivative of the position function. So you take the derivative, and you can take the derivative of the derivative, and that is being called the acceleration function. In physics, we try to figure out the value of the acceleration by studying the force. Force is equal to acceleration multiplied by the mass, and that's something we study in physics. So then the actual physical motion can be connected to the quantity of the mass, the physical, the mass, and then something that's more abstract can be connected with something that's solid. So anyway, this is something that we will come back to again, because the relation between the original function, derivative function, and then second derivative. Right? We have an example in the So this is about the velocity. So suppose the position function, and this is a distance function modeled by this. You can see sometimes the distance is changing fast. Sometimes they slow down. There's normal change from this hour to this hour. And so maybe this person stopped. So from this time to this time, there's no change to the position. How come there's no position change? You stay there. So the rate of change or the velocity equal to 0. So here the velocity is almost 0. That's because maybe you stop the car and start eating lunch or something. So then you can look by the change of position function, we can identify the change of the velocity. And change of velocity is constantly changing. So this is moving fast, to stop moving for a while and then moving in that same direction. All right. Now this is the first example. The question is to try to find. At first, we try to find the average velocity. That's really the slope of the graph, slope of the function. And then second question is to estimate the instantaneous velocity. That is try to estimate the tangent line, slope of the tangent line, the derivative value. Let me try to figure out, explain the example. So for example, the first one, if you want to find the average velocity over 0 to 1. This is 0, this is 1. So at 0 is 0, 0. At 1 is 1, 15. So that is roughly in 1 hour, we move 15 miles. So that's basically 15 miles per hour, right? Our slope, right? So it ends up 15 miles per hour. That's really calculation of slopes. You have the subtraction of the y value, which is 15 minus 0, and subtraction of the x value, which is 1 minus 0. And then the next question is, what is the average velocity from 1 to 2.5? So over here, this is 1, this is 2.5. All right, a little bit hard to estimate it. It says estimate, so you're allowed to have a little bit error. I guess that's not so visual. I can see it over here, but this is 15 if I connect it. So that's 15, this is 1. So it's 15 over 1. It's pretty easy to see it. But the second question I want to look at is estimating the So from 1.5, 1 is right here, and 2.5 is here. Estimating the velocity, so we're trying to find the slope. This point is 1 for the time and 15 for the position. Now this one is 2.5 for the time. 21, let's assume. Okay, so then you work on trying to figure out the slope. You will subtract the y value and subtract the x value. 21 minus 15 is 6. And 2.5 minus 1 is 1.5. So you can go 6 divided by 1.5, that's roughly 4. So you can see it's moving a lot slower in this time frame. I mean, from 0 to 1, obviously we're moving faster there. Okay there. Question. So this is a slope calculation. We answer 4. Okay. Roughly 4. Those are the first two questions. I believe the next question can be done very similarly. Identify at 2.5, and I think that's roughly 21. And then the 3.5, that's roughly 39, maybe. So we can use those numbers for calculation. Don't need you to do that question. And then the next question, we want to estimate what is the instantaneous velocity at t equal 1/2. So that is we're trying to estimate right here what was the slope. To me, it's very similar to the slope over here, right? If you kind of draw a slope, it's similar to what happened here, right? Right? Seems to be parallel. If you draw a slope of the tangent line right here. So I'll estimate the same thing as that estimation is. It says approximately, so that's okay. And second question was to estimate what is the velocity at 2, or what was the slope of the tangent line at 2? 2, which is right here, right? To me, that looks very much horizontally. I think that if you try to draw a tangent line, it will be horizontal. Therefore, the slope would be 0. So I think by looking at the graph, I feel like that should be a 0 there. And so it says approximation. So there is a small deviation is fine as long as you're close enough. So I think the computer will be forgiving if you are not too much off. This next question, want to calculate the slope at 3. It's right here. It's a little bit harder. So if you want to find out what the slope here, I guess you can find these 2 points. This is 35 to 25 as the distance. Subtraction of distance is 10. So what is the time? 3.2. I mean, this may be 2.3. So you can subtract 3.2 is 2.3 and find the slope. Basically, the derivative value, the instantaneous velocity, is the slope of the tangent line. So you're going to try to figure out what is that slope. To me, that looks much faster than here. So here is this, and then slower and slower, and then this is a much faster change, right? We should have a higher slope. Over here is 15. I'm guessing here is higher than 15, maybe 20, 25. You can estimate it, or you can go ahead and calculate it. Using the x value of 2.3, 2.4, and then 25. And then over here is 3.2, and then 35. So using those 2 points, you can calculate the slope and estimating the slope of the tangent. Any question? Explains. So whenever the graph is given, there are some estimation going on. Limits of expression estimate maximum velocity at specific time limit first. I'm thinking that spot. Right? Here we go. This direction, and this direction, then slow down again. This is a slope. faster slope, slower, 0, and then speed up again, and then slow down again. So I think this is the spot where this slope is maximum. This is question number 1. We have a graph, and we think of the relation between the position function and the velocity. Velocity is the slope of the tangent on the derivative. All right. This is again another very tough topic. So let's talk about what does it mean. We basically look at the graph. This is the graph showing the slope of the tangent line of the original function. So this is the part that's making it harder to do because the graph is not the graph of the original function. This is actually the graph of the derivative, or the graph of the slope of the tangent line, which basically means a derivative. So this graph is a derivative function. So we have to indirectly think about the change. I'm showing you the slope graph is slope of the original function. And therefore it says here the slope is also called the derivative. So we already have this is the graph of the derivative. So each of the interval enter all the letters corresponding thing are true for the interval. Now the interval from A to B is over here, and realize that the graph is the derivative function. Okay, not the original function, this is a derivative. So this part is when the derivative is negative. You know, kind of have to think about what happened to the original function. Now, if the derivative is negative, means that the graph is going down. If the derivative is positive, then the original graph is going up. So the positive part of the derivative is when the function is up, but the negative part of the derivative is when the function is going down. When the derivative included 0 is when the function is roughly, approximately 0 change. So it looks like the function is decreasing, then increasing, then decreasing here, and then increasing again. So that's what happened. So we can see from A to B, the derivative is negative. So the original function must be increasing. Yes. So it's slope of the original function is positive on this interval. But you can see the function is the slope of the original. This is negative. So we should enter the slope of the original function is negative on the interval. So that one should be B. So we realize that A and B are opposite. A says the slope is positive. B says the slope is negative. So on each of these intervals, they're either negative or positive. So A and B, you have to choose one to put in all 5. So then we can try to look at it, whether it's A or B. So from this interval A to B, it's negative. So I write B. D to E, E to F is also negative. So that also should be B. But then from B to C, it's positive. C to D is also positive. So these two should be A. I'm trying to assign A and B to all of them. There's A. Interval from D to E. D to E is negative, so that must be B. And interval from E to F is also negative. That must be. So A represent the function is negative. The graph is negative. B represent the graph is positive. So we're assigning positive and negative to it. Are we okay? Now, this horizontal line is separate positive and negative there, right? Right? So this A to B on horizontal line, this piece is negative. Yes.
Isn't it saying that the slope of that's positive, not that it's actually negative?
Right. But the graph is the slope of the function.
Oh,
it says that the graph is shown is the slope of the line. So that is really the slope of the area. So that's why I'm trying to assign negative, positive to it. So this is a physical negative, positive, positive, negative, negative, positive. And so there will be B, A, B, B, and A. We actually have the last one. We don't have F to G, so it's just A to B, C to C, C to D. Yes. Any question? Are you okay? We're filling out A and B, and then we're gonna try to fill out C and D because they're opposite. C says the slope of the function is increasing. B says slope of the function is decreasing. Okay, are we okay there? So we finished with A and B. Then we try to finish C and D. C and D is indicating whether the function is increasing or decreasing. Then you can see it. Increasing, increasing, decreasing, decreasing, increasing, increasing. Are we okay? So we're gonna try to assign from A to B, increasing or decreasing. So it's increasing. So if which one says increasing? That is C. So all part that has increasing will go C. B to C is also increasing. Then E to F is also increasing. Putting that C there. And D represent decreasing as D in decreasing. So C to D is decreasing. And B to E is decreasing. So we assign to all sides, you either assign a C or assign a D. Because C and D are opposite. And there's no horizontal, so it's either increasing or decreasing. Are we done with C and D? The statement afterwards. The original function is increasing on this interval. The original function is decreasing on this interval. So E and F are not talking about derivative increasing or decreasing anymore. It's talking about the original function. The original function would be increasing if the derivative is increasing. The original function will be decreasing if the derivative is the original function will be increasing if the derivative is positive. So derivative positive function is increasing, derivative negative function is decreasing. So derivative, which indicating the direction, positive direction or negative direction, is increasing whether the graph is going this way or this way. So these two goes together with the positive. If it's positive, it's increasing original function. Derivative positive, original function increasing. Derivative negative, original function decreasing. So it goes with the A and B. So whenever you see an A, you always write E. Whenever you see a B, you always write an F. That's how we're going to assign E and F. Are we okay? Go back and try to assign E. Whenever you see an A, you write E. So this is the E. If you see an A, you write an E. Whenever you see a B, write F. So we have F here, F here, and here. Then finish assigning E and F. So derivative, positive or negative, causes the original function to be increasing or decreasing. Finish E and F. Any questions? So since we have to fill multiple choice for each one, to try to make it complete, we have to finish every one. These statements are opposite. That's why I had to assign some to each one. Now, G and H. The shape of the original function is concave up, and the shape of the function is concave down. That is a little early for that topic. Let's talk about concavity. So what's concavity? It's related to the derivative function. So if you got a function, let's talk about the original function. If it's a function in this way, and we call it concave down. Okay, open down. I mean, if it's this way, if it's open this way, for the original function, we call this concave up. All right. Now, if the function goes this way, there's no concavity. Okay, 0. All right. So this one, how do we tell for the derivative? You see, the derivative will be. This is the derivative. Derivative is positive here, and the derivative will be negative here. So whenever the function is increasing, the derivative will be positive. If it's decreasing, the derivative will be negative. So if the derivative is positive, then negative, which means when it's concave down, the derivative will be decreasing. It will turn from a higher derivative to a lower value derivative. Now this one here, it's going down, it's decreasing. So the derivative is actually negative. Over here, the direction goes up. This derivative actually is positive. And then over here, the derivative is 0. Okay, so negative, 0, positive, which indicated that derivative function actually is the first derivative function. Negative, 0, positive. It's increasing. So the derivative function increasing or decreasing is indicating the contivity of where we're going. So we are looking at whether it's increasing or decreasing. We already had some decision on increasing, decreasing, because this function is not the original. It's the derivative. This is increasing, and that indicated concave up. This is decreasing, that indicated concave down. So we can start identifying the activity using the increasing, decreasing. The derivative increasing is concave up. So whenever you see the C is when it's increasing in the derivative. That's connected with the shape of the function being concave up. So whenever you see a C, you write a G. Whenever you see a D, you write a H. So C with G. The one that has a C, we write down G. This one has a C, so we write a G. Anyone else that has a C, this one has a G. So whenever you see a C, is write a G. Now D is indicating the derivative's negative derivative decreasing, and therefore that's concave down. So whenever you see a D, we already have the D and D assigned. If you see a D, you also basically write an H, because D and H are the same thing. Are we okay? So we know there's a D, there's a D, so we write a H right there. H. That way we finish. There's 8 statements, but they're opposite of each other. So every statement, every interval, you have to assign 4 statements to it. It's making it slightly harder. We gotta understand the logic behind it. Any questions? Right. Let's finish all 4, all 5, and I hope that you can find some of the underlying reasoning for how do we use the derivative to understand the original. So many of the statement is about what happened to the original. If you only have the derivative function, we don't have the original function, we only have the derivative function. This is the second question. Again, connected to the geometric meaning with your original function. So we try to think about if you have the derivative, what does it tell you about this function? All right. Question 3 is quite abstract because it has a physical background, but then also the statement is explained. Okay, let's try to read through this. Relation between diet and weight. So we have W represent the weight, and what was the C? C is representing calorie. C as in calorie, W as in weight. So the first one we got, it says after 1,500, you put 150. This is calorie, and this is a weight, right? W represent the weight, and then whatever you enter as a C, represent the calorie. So what is the unit of 150? It's calorie. So let me unit. What is unit? I know the W is pounds, right? We already had the W is in pounds. That is this unit. Now this one is calorie. What is the calorie? C. This one, right? Okay, so the first one is understanding the term, the information in the statement. Second statement says the derivative equal to 0 at 2,000, meaning that the change, I mean, remember derivative represents the rate of change. So the rate of change at 2,000 calories is 0. meaning that if you consume 2,000 calories a day, there's no change to your weight. So I guess the unit of the 2,000 is still going to be the calorie, and unit of 0, I think that's still the change of the weight. Or maybe that should be it's DWDC, so it should be pounds per calorie. So we can kind of see that this is W equal to C, all right? So the derivative of W, which is representing F prime of C, can also be represented as BWEC. So the unit of it, the W, it has pounds, and the calories has unit. So the derivative should have a unit pounds per calorie. Just from the notation itself, I hope that helps clarify the unit of the value. And the statement, this is the inverse notation. So in this case, if you inverse it, then that is a calorie. This is a weight. So we have to switch them. 150 is how much the weight and that calorie consumption. So this is a calorie. This is pounds. Right. And what are the units of the derivative? I already mentioned it. It has to be pounds per calorie since there's division involved in the derivative calculation. Is pounds per calorie. Last question about the calculation. We're out of time, but overall, the first question are okay. And as you see, the last question probably involved a little bit calculation. We might have to divide it. We'll figure it out next time. That'll be a mistake. I hope that allows you to start your session soon. They'll replace the if you make it higher. Do they lower the reduction?
Yeah, and then she's I'm gonna turn this one off if you want to come get us.
Did you do the attendance question? Is yours?
No, I'm just waiting on.
You have your card?
Yeah.
Can you give me a date so the way to schedule it?
Yeah.
No, you want to go online to schedule it. You click on admission, testing center, and then schedule exam. You can choose mathematics and choose. And then this is log in. There's no cost, but there's a cost if you miss it and didn't cancel. If you change your schedule and then you want to change your schedule, you have to let them know ahead of time, so they will reschedule or cancel it. But if you don't tell them, I think they charge you $10 for not attending the exam. You try to schedule, once you pick your time and date, let me know. I'll send it ahead of time and also confirm with you, hey, I sent your exam. That way you know the exam is there. I know I sent the exam. That way they communicate enough, so you go there, the exam is already printed. I had a student that didn't tell me that they taken the exam. They went there, there's no exam, so we have to communicate. So once you receive a response from me, if they know you're going to the exam, I know I send your exam, you know I send your exam, then everything works out. Yeah, there's a website online.
Email then or something, once I set that up for you, or I can just tell you in person.
You can tell me in person or send me an email,
Okay.
either way.
All right. Thank you, that helps.
You wanna the attendance question?
Yeah, for Just right now.
Yeah, this is for attendance. You know the answer is
Yeah.
C. We cancel the common factor X to get the answer. Thank you.